Hey everybody, this is Mr. D's. Today we're going to be going over the Chapter 3 exam review. Oh yeah, test is this Friday. Hope it goes good for you, or at least pretty close to this Friday. So don't forget to put your name on the paper. D's. Booyah! And I thought I'd just make you jealous. It's very hot, so I'm going to take my sparkling water here. You hear that? That's the sound of refreshment. Ah, yum. Don't forget to subscribe to the YouTube channel, and that way any videos, when they're published, it'll just send you an email saying, hey, the next review is up, and you can click on the link rather than having to go look for it. Here we go. For the following sets of data, write them as a table, a map, and a graph. For each, determine the domain, the range, and whether or not it's a function. So here we go. Let's go ahead and write this data right here. This is a set of ordered pairs. So let's go ahead and write the data as a table. It'll be a series of xy values. So -5 is an x value, -2, 1, 2, and 5 are x values. The y values are 1, -1, -2, -4, and -1. Notice what we've done is we've grouped each x value with its own y value. Okay? Alright, so that's that part. Check. As a map. Now a map goes from a group of x's to a group of y's. We don't need to write down any repeats. So in here there's -5, -2, 1, 2, and 5. And over here there's 1, -1, -2, -4, and -1 has already been listed. Now what do we do with these? Well, we kind of draw an arrow showing the connection between input and output. So -5 goes in, it gets turned into, if you will, a 1 over there like that. -2 is associated or linked up with -1. Excuse me, 1 is associated with -2. 2 is associated with 4. And then 5 is associated with -1. So we kind of go over there like that. So that's a mapping or a map. As for a graph, well, they already were so kind as to supply the coordinate plane, or the xy axes, and so I would just plot these ordered pairs. We know that this is the x-axis and this is the y-axis. -5, 1, 2, 3, 4, 5 to the left, up 1, 2 to the left, down 1, right? -2, -1 is 2 left, down 1. 1, -2 is 1 to the right and 2 down. 2, -4 is 2 to the right and 4 down. And 5, -1 is 5 to the right and 1 down. So there's the graph. Now it says for each. But really, what I'm about to say applies to all 4 of these relations. This one, this one, this one, and this one. They're all the same thing. Let me say that again. They're all the same thing expressed differently. So if I were to say to you, hi, my name is Mr. D's, this is my spouse Jennifer, that means the same thing as Jennifer, my spouse, and I am Mr. D's. Something like that. It's just kind of switching the way that the information looks, but it means the same thing. So anyways, here we go. The domain. The domain, usually it's right in a set brace, are all the x values. -5, -2, 1, 2, and 5. Now notice I moved my fingers all over the place because I want to show you could have gotten them anywhere. The range is 1, -1, -2, -4, and I need not write -1 again. Notice they don't even have to be in order. Is it a function? The answer is yes. Why is it a function here? Well, your teachers might have talked about it passes a vertical line test. It only touches once. Everywhere I draw a vertical line, yes, a function. How can I see that it's a function here? Because every single x value has a unique y value associated with it. So how about over here? Well, you don't see the same x value being associated with two different y values. You do see a y value getting associated with two different x values. So anyways, I know that's pretty tough, but remember, each unique input has only one unique output. That's kind of the way to think of a function, okay? All right, good. Number 2. Mom's new iPhone with 32 gigabytes of storage. You know, interesting, I don't think the new iPhone has 32. It jumps from 16 to 64. Yeah, go figure. The function I of x, that doesn't say I times x, it says I of x is 32 minus 0.5x, represents the available storage remaining after each movie X is downloaded onto our phone. So you're going to download some movies, and that's going to make the amount of free space or available storage go down, right? So let's plug in 0 movies. So I would plug in 0 right here for X, 32 minus 0.5 times 0. So, but that's 32 minus 0, 32. Now why does that make sense? Well, obviously if I haven't put any movies on, then it's still at full capacity. 0 movies, still 32 gigabytes. Now let's plug in 4 in for the number of movies. 32 minus 0.5 times 4. And hopefully you have your handy dandy calculator accessible. This is 32 minus 4 times a half is 2, so that's 30. So 30 gigabytes. And so on and so forth. I'm not going to write all these out because you can just alter this number to be 12, 20, 32, and 40. 12 times a half is 6. 32 minus 6, 26. 20 times a half is 10. 32 minus 10, 22 gigabytes left. 32 in here. Half of 32 is 16. 32 minus 16, 16 gigabytes. 40 times a half, or 0.5, is 20. 32 minus 20 is 12 gigabytes left. So there's the table from 0 to 40 movies. It says now graph the function from part A. So, you know, really I can afford to zoom in just a little bit. Alright, good, we just fit. So I'm going to go ahead, and now it says specify the scale. So the number of movies, it goes up to 40 movies. So, I'll go by 4s. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. Really, you only need that first one right there, but you should definitely check with your teacher. But as long as they're going by equal increments. Now, what about the amount of free space, remaining storage? It says right here, it's kind of light. You can't quite see it on here. Here, if I go like that, you can see it. Remaining storage. It goes from, it starts up at 32 and then goes down. So if I went by 4s again, 4, 8, 12, 16, 24, 28, 32, 36, 40. Oh, 32 is as high as I need to go. 1, 2, 3, 4, 5, 6, 7. Oh, I messed up. That's 28. Woo, good thing I counted. 28 and then 32. Okay? Sorry about that. A little messy, but we got it. We got it. All right, so let's plot these ordered pairs. At 0, it's 32. At 4, it's 30, which is halfway between 28 and 32. At 12, I'm at 26. Oh man, I messed up. Man. 4, 8, 12, 16. This is 20. My apologies, guys. Hey, teachers make mistakes. I know you see it all the time in class. So that's going to be 28. 20, 24, 28, 32. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So at 12, I'm up at 26. So I go 12 over and up to 26, which is just shy of 28 right there. At 20, I'm at 22. So 20 goes in, the number of movies. 22 comes out, which is just above 20. At 32 movies, I'm at 16 gigabytes left. So 32 movies is right here. 16 gigabytes. 1, 2, 3, 4. 4 fours. And over at 40, I'm at 12, which is 3 fours. Boom. Now, this is me graphing the function. Notice, I don't know exactly what your teacher wants. I don't know if they want us to graph a linear relationship as a function, or to graph, you know, these ordered pairs right here, which is a function. So not quite sure. Yeah, so you should specify with your teacher there. Really, we can't really put, I mean, theoretically, I don't know how an iPhone works in this way, but could you put a half a movie on your iPhone? Well, probably. I don't think we would, but we could put a half a movie on there. We could, you know, put 1.5 movies on there and 2.5, but I would think that they're just whole numbers. So we'll see in a minute. Okay. Well, guess what? That addresses question C here. It says discrete or continuous, and why. Well, what does discrete mean? It means it's in chunks. You know, like we were just saying, if you went to a donut store, I doubt that would be discrete, because you buy either 1 donut or 2 or 4 or 9 or whatever. Now, even if you could buy 1.5 donuts, which I've never seen that before, you wouldn't be able to buy any portion of a donut, 1 and 2/7 of a donut. So that would be a discrete thing. Continuous is more like if you're filling up a tank of water, and it just gets gradually higher and higher and higher without jumping from 1 gallon to 2 gallons or 1 gallon to 1.5. It's always continuing smoothly. So this one here, I guess it depends. It depends on the nature of an iPhone. I'm going to say continuous. Why? Because you could put part of a movie on your phone. Okay? And now I don't know if that's how an iPhone works. I have an iPhone, but I don't put movies on it. So anyways, you can come correct me if I'm wrong, but if it would be, the answer would be discrete if you could only put whole movies on the iPhone. All right. What does the domain represent? So what did these x values represent? That represented the number of movies on the phone. What are the limitations of the domain? Well, the limitations are that the domain can't be, like, what wouldn't make sense? The number of movies. The domain can't be negative, right? You can't put negative movies on. And must be, and as all of us know who have any kind of digital device, phone, do they even have a PDA anymore? Not a public display of affection, by the way. No, a personal digital assistant. I don't know if they have those anymore. The domain can't be negative, but you're going to run out of space at some point. And for those that are in the know-how here, it must be less than or equal to 64 movies. And the reason why is because 64 movies would be 32 gigabytes. And so therefore you're all tapped out, and that's without using any other storage at all. So the domain can't be negative, and it must be less than or equal to 64 movies. Great. What does the range represent? So what did this count for right here? What were those numbers all about? That was the remaining storage in gigabytes after so many movies were loaded on the phone. Okay? Look at that beautiful handwriting. The remaining storage in gigabytes after so many movies. How much memory was left after 24 were downloaded? So we would simply take 32, our function, I of x, equals 32 minus 0.5 times x, right? But now we're going to plug in 24 into the function. What's half of 24, everybody? That's 12. What's 32 minus 12? 20 gigabytes. Now, notice, it's a word question. How much memory was left? Answer in words. 20 gigabytes is left. Okay? Great. Next page. I'm sure while you're switching there, you could pause it right now, right? Pause that video and go try these and then come back and see how we did. I can't pause it while I take a drink of my refreshing sparkling water. And so there you go. Sorry. Here we go. This one's pretty straightforward, actually. These are real nice. I mean, they're pretty straightforward. I kind of don't care for them myself, but we know that these are going to be coming at you on some tests you're taking soon, and well, it's handy to know for that. Basically, these are called combinations of functions, not compositions, but combinations of functions, and you simply just do what it says. Take function f and add it to function g. Function f is 5x minus 6. We're going to add function g 2x. But these are like terms, so we get 7x minus 6. Alright, boring. Here we go. F of x is 3x plus 6 minus g of x, which is 3x. These are like terms. 3x minus 3x is 0. All you have is 6 left. Boom. Okay? Now this says f of x times g of x. So it's 7x minus 1, that's f of x, times 5. This 5 can be distributed in, and we would get 35x minus 5. Boom. And now it gets a little more interesting. First it says to find f of 2. So I need to plug 2 into the function there where x is. Everywhere I see an x, I put a 2. So that's now 6 plus 6, which is 12. G of 7, okay, is going to be 3 times 7, which is 21. And now what do I need to do? Well, it says find f of 2, which is 12, minus g of 7, which is 21. Don't mess this up, guys. Come on now. It's not 11. It's not even 9. It's negative 9. Okay? You got to be real careful with that stuff because it's your grade. All right? So be careful. All right. Given the function 5x minus 2y equals negative 10, find the intercepts and graph it. Now how do we find the intercepts? Well, I'm not exactly sure how your teachers told you to find the intercepts. The way I do it is this. To find the x-intercept, we plug in 0 for y. To find the y-intercept, we plug in 0 for x. So if I plug in 0 for x here, or 0 for y, what's 2 times 0? Well, that's 0, and it kind of goes away. And so some of your teachers might have said, use this cover-up method. So how would I, right now, for this part it says 5x equals negative 10. And from an earlier chapter, how would you solve for x? Well, you divide by 5. 10 divided by negative 5 is negative 2. And what we just found is the x-intercept. 2 to the left, 0 up and down. So that's one of the points that form this line. Going back now and plugging in 0 for x, that disappears. And how would I solve for y? I would divide by negative 2 everywhere. Those are gone. Negative 10 over negative 2 is positive 5. So I plot that y-intercept, 1, 2, 3, 4, 5. And now I can connect those. I don't know if your teacher is going to want precision or anything like that, but I suppose the neater the better. And there you go. That's the graph of this line. It's really pretty easy to graph a line using the intercepts. Number 8. Together, these will give me, okay, wait, no. Identify all the indicated features of the given graph. Well, this question, it's kind of tricky if you weren't there for the review. I mean, on the test, if this was on the test, you just wouldn't know what to do, probably. So let me just try to think of it like this. What is this circle indicating? What is it around? It's kind of indicating that point right there. But what do we call that point? See, that's what it's going for. It's going for the x-intercept is, and where is that ordered pair? Assuming these go by 1, it's at 1, 2, 3, 0. Likewise, this guy right here is right there. That would be the y-intercept because it's where the line touches the y-axis. The y-intercept is 0 left and right, but then 2 down. So 0, negative 2. Okay? Alright. Together, these will give me, no, not there yet. So like, what's up with these little funny symbols here? Well, from this point to this point, notice what I'm doing. I'm rising 2, so that's what they're going for here, rise 2, and then they're indicating here we run 3. So what's the definition of the slope? Together, these will give me the slope, which is m equals rise over run 2/3. Okay? Great. Study that. Work backwards. Try drawing one on your own and seeing how you'd be able to do. It says graph f of x. Now, how do we graph a absolute value function? Absolute value function, absolute what? Value. V. So they're shaped like a V. And the parent function for that family of graphs is at 0, 0 and goes up with a slope of 1 and then also up with a slope of negative 1, like that. So it has its origin, if you will, the vertex part at 0, 0, goes up 1 over 1, up 1, back 1, kind of like that. Real clean like, okay? You could keep going. Now it says graph this. Well, you know, you could make an XY table, and that's really a good option if you understand the basics of what functions are and how they work. You can do that and you'll get the answer. I think what your teachers are going for is hoping that you've internalized what these things do to the original parent function. So it says x plus 2. What did this plus 2 do to the graph inside the function there? Well, plus 2 would make me actually move it 2 to the left. 2 to the left, because I'm in there with x, so it's going to go 2 to the left everywhere. So that's the new vertex. And then what does this minus do? Well, that flips the entire function like over the x-axis. Called a vertical flip. And so instead of going up 1 and over 1, it's going to go down 1 and over 1, down 1 and over 1, like that. Presumably, they want us to label it. This is function f, and this is function g, right there. Now it says describe the transformation. G of x is shifted 2 to the left from, from f of x and flipped vertically. Now there's lots of ways to say what I just wrote. G of x is shifted 2 to the left from f of x, and it's flipped vertically. Alright, so let's move on to number 10. Alright, what's this say? Yeah, we got it. Using f of x equals the absolute value of x, describe the transformations from the graph f of x to g of x. So really they want us to do this 5 times without drawing the picture, okay? So here we go. What does a minus 3 do outside of the parent function when you kind of tack it on the back? It shifts it down 3. So if that was a plus 2, we would have went up 2. If that was a minus 2.5, it would be down 2.5. It's a translation, maybe your teachers are calling it, but a shift is fine. G of x here. Negative, we already discussed that, didn't we? We discussed it right here with this. What did that negative do? It is a... Who said it? Who said that? Oh, good. Johnny, good job. You said it. It is shifts it. Oh, no, it's a vertical flip. And you might want to write for clarity over the x-axis. Alright, what's a 2 do? Well, what that's going to do, if I had to graph it, it doesn't move the starting place, the vertex, but now the slope of each arm of this V going out would be up 2 over 1. Up 2, back 1. Making, instead of being up 1 over 1 like this, you know, it's going to be kind of narrower. I believe the last time I saw this, it was called a vertical stretch. Vertical stretch, it makes it skinnier. Alright? So for those of us that want to maybe lose a little weight, that's what we do when we look in the mirror, right? We multiply by 2 and it stretches us out. Alright. X minus 3. Now that's like the one in number 9 that we did together. That's going to be a shift of 3. Here, shift 3 units. But which way? Which way? Well, it's kind of like when you're dealing inside of the thing, it's like the opposite. So that would be to the right. Because it looks like it says negative 3. So it's going to be shifted to the right. Positive 3. And now they think they can mess with us, but we got it. So what? They put two questions in one, but we got it. We already know what this minus 3 does from part A. What does it do? Shift down 3 units. And then big deal, we put and, right? And what? 2 units. Shift 2 units, but which way? Well, because you remember, when it's inside, you do the opposite. So since that says plus 2, that means we're going to go to the left. 2 units left. Boom. Can't touch this. Alright? Here we go. I know, and that's a reference from my high school, to give you a little context. Here we go. 11. Graph each of the following lines. Are they horizontal or vertical? Is their slope 0 or undefined? And look at, they guys got all laid out nice and sweet. Guys, you just got to get this memorized, and that's what this is designed to do. X equals 4. Let me go to x equals 4, right there. Guys, would it make sense to draw a horizontal line right now? No, because it would be the x-axis. And that wouldn't make sense to go 4 to the right and then draw a line right and left. And what makes sense is to draw a line up and down. And what's the slope of a vertical line? Undefined. U-N-D. And that's vertical. Up and down. Look, it's x again, so it's vertical. Let's just get this out of the way. Y, horizontal. y, horizontal, x, vertical, y, horizontal. Okay, get that memorized, please. Okay, you still got calculus, or maybe calculus, I never taught it, but pre-cal students that keep forgetting that. You just commit it to memory, okay? It's gonna make your life easier. Now let me go to where x is -4, 1, 2, 3, 4, put a dot, and draw a vertical line. What is the slope of a vertical line? Undefined. What's the slope of a horizontal line? 0. What's the slope of a horizontal line? 0. The slope of a vertical line? Undefined. What's the slope of a horizontal line? 0. Get those memorized. Okay? Be the robot. Alright, here we go. Y equals -4. 1, 2, 3, 4. What kind of a line would make sense to draw right now? Horizontal or vertical? Horizontal, man. Okay? Same down here. Y is 4. 1, 2, 3, 4. Horizontal. X is -2. 1, 2. Vertical. We know this. Thank you for the free points. Right? That's what you should be thinking. You hand that, when you take this test, hand it to your teacher and say, thank you for the free points. Boom. Okay. Y equals 5. 1, 2, 3, 4, 5. Horizontal. Alright. And now, graphing these, it gets a little bit hectic. So let me zoom on in. Give us a little more space here. Boom. We're going to do the x and y intercepts, but now I'm going to do a little bit quicker. That's right. Okay. Because you know what? The more time we spend doing these sometimes, the more discouraging it is to actually do the math. I get it. So to find the x-intercept, we cover up the y term and solve for x. 5 times how much is 15? 3. So immediately we go to x equals 3 and put a dot. To find the y-intercept, I cover up the x term and divide by 3. 3 times how much is 15? 5. 1, 2, 3, 4, 5. And you connect those lines. Okay. Boom. Done. You can't mess with me. We got it. Let's go to this one. Same thing. So what? The numbers come out yucky. You got a calculator, right? Cover this up. How would I get x by itself? No, man, don't add 2. Come on. You divide by -2. 21 divided by -2. -10.5. Okay? Go over here. How would I get y by itself? I divide by 7. Not subtract it, divide. 21 over 7, 3. But now we got to go by 2's or something, right? Go by 2. Go by 2 because we can't afford to have 10 spaces. So here we go. -10.5. 2, 4, 6, 8, 10.5. The y-intercept. 2, 4, 3 is right in the middle. Look at that. Beautiful. Easy. Easy peasy. Okay? Blammo. Alright, 2 left. Yes. So you know why I need this right here? The sparkling water? That's what that is. Because it's almost 3 o'clock and it's like 90 degrees and I'm on the 2nd floor with no AC. You know what I'm saying? Take that. Listen to this. Ah, refreshing. Here we go. How do we graph these? Well, I don't know exactly how your teachers are doing it, but when it's in slope-intercept form, when it's y equals mx plus b, it's best to identify the m value, 4/9, and the b value, 4/3, and then to actually just plot those values rather than using intercepts. So the y-intercept here is 4/3. Now the y-intercept is where it crosses the y-axis. Now how much is 4/3? Well, that's about 1.3. So if I went up to 1.3 and put a dot, that's good. We have the y-intercept now. But now I need to do a slope of 4/9. As we saw 2 pages ago, the slope is rise over run. So I need to rise 4, run 9? Yep. So what? We go off the paper, no big deal. Or off the grid. There's rising 1. Now go over 1, 2, 4, rise 4, excuse me. 1, 2, 3, 4. That's rising 4. Then running 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Seriously, that's just beautiful. Okay? It's a beautiful thing we just did. Okay? Go tell the world. We just graph that line in slope-intercept form. You plot the y-intercept, everybody. That's the constant. That's the number without the variable. You plot it on the y-axis. From that number, you rise and run. Rise 4, run 9, connecto. Boom. Okay? So what's m in this problem? It's the coefficient of x, 3/2. What's the b value? I use a capital B because if I don't, it looks like a 6. What's the b value? Negative 9/2, negative 4.5. Okay, so watch. Down, we do this first, always, right here. 1, 2, 3, 4.5. And we put that there. Then from there, what do? Rise and run. Rise 3 from here. 1, 2, 3, run 2. That's it. Everybody else gets to go home, not Mr. D's. But guess what? I'm done. All done. Guys, come on now. Watch this thing again. You got time, right? So watch it, share with friends, come in and say hi to me. I do tutoring in the morning. Mr. Kompleski does it after school in room 203. I'm in 260. Let's do this, man. Time to get an A. I'm done.